Okay, video number 2. Now that you remember the 3 basic trig functions, we've got sine, cosine, and tangent. Remember we were going to use SOH to remember the formula for sine, which is going to be, we're going to abbreviate sine OPP for the opposite side over, whoa, not that one. Let's erase that. Over, it should be hypotenuse. Cosine is going to be adjacent over hypotenuse. We'll abbreviate that CAH. And tangent is TOA, so it's going to be opposite over adjacent. Now the other 3, if you know these 3, the other 3 are easy because they're just reciprocal functions. The word reciprocal just means flip it over. So here's my cute little picture to show flip it over. So cosecant is going to be the sine function flipped over. So cosecant, parts of the triangle formula is what I like to call it, is going to be hypotenuse over opposite. Secant is going to be hypotenuse over adjacent. And cotangent is just the tangent's reciprocal, so we're going to flip the tangent formula over and use adjacent over opposite. Now, doing this thing where we flip them over because they're reciprocals works when we're doing the formulas with the parts, but it also works once you know the numbers. So if I know a number, a ratio or a fraction for sine, if I want the cosecant, I'm just going to take that fraction and flip it over, and I've got my cosecant. Right here, my note about listing these in order. I highly recommend this. You're going to see problems where they say find all 6 trig functions, and I believe those are going to be, I put it up here, this number 5, 7, and 9 on your Big Ideas assignment. When you see those, you're going to list your 6 functions in this order, although when you type them in, they're going to be listed in that order. So if you have these listed in order, when you go from this left side to this right side, you just flip the fraction over. Or it works going back the other way. We can go from the right side back to the left and flip the fraction over. So I just memorized the first 3, and then I have to remember that sine goes with cosecant, and that's really, I think, the only tricky part, because cotangent, tangent, those go together. That seems kind of obvious. So here's my silly little trick. When I'm trying to remember if sine goes with cosecant or secant, I notice that when I look at those 6 formulas up there, if I start with a S in one formula, then the one it gets paired with starts with C. So sine wouldn't go with secant because those would both start with S. It's a silly thing, but it works for me. So cosine starts with a C, so it's going to get paired with the function that starts with S. So it has to be a C and an S on the first parts of the 2 functions. So if that works for you, use it. It works pretty well for me. Then, if I have a triangle and I want to solve for all 6 of the trig functions, let's say we have this triangle right here, and we'll walk through the steps together. In this triangle, I've got my angle theta marked. I'm going to make the hypotenuse 12. And let's make from theta, this side across from it is 6. Now the first thing we want to do is identify the parts of the triangle that we know. So from theta right here, across through the center of the triangle, this is now going to be my opposite side. I'm going to actually write OPP right on my worksheet, right on my paper. If you have to draw this on your paper, draw it on your paper and do this labeling. Hypotenuse is always across from the 90-degree angle, that's y. And that makes this angle over here, or this side next to theta, my adjacent. Now if I'm going to do all 6 trig functions, I'm going to need sine theta, cosine theta. You'll get to where you can remember these and get them in order, no problem. Tangent theta. And then I'm going to use my S and C combination. Sine is going to go with cosecant. Cosine is going to go with secant. Those are reciprocal functions. They're the ones they're paired up with. And cotangent goes with tangent. So all I have to do now is use my parts of my triangle formulas. They're technically called the ratios, but I like the parts of the triangle formulas. So from my angle theta that was given to me, my opposite is 6. So I like to do this just to remind myself of my formulas. Opposite over hypotenuse. My opposite side is 6. My hypotenuse is 12. My cosine, oh no, I need my adjacent side. I don't know that. So we're going to use that adjacent. We're going to use that fourth formula that we know for right triangles, our good old friend, the Pythagorean theorem. Remember, in the Pythagorean theorem, you have to use the hypotenuse in there for the c. So now I'm going to look at my picture, and I'm going to see my hypotenuse is 12, so I'm going to put that in first thing. I'm going to put a 12 squared right here. And then the a and the b don't matter, so I'm going to call the missing side x just because we like x. Could be any letter you want it to be. And the other side I know is the opposite side, which is 6. Order of operations says we got to do exponents before we can do anything else, so I'm going to go ahead and square my 6 and get a 36. I'm going to square my 12 and get a 144. See if I can squeeze this in here. Then, when I go to solve for x, I'm going to subtract 36 from both sides. When I do that, I'm out of room. I'm going to have to come up here. I'm going to have my x squared is equal to 108 when I do that subtraction. But I don't want x squared, I want x, so we're going to square root both sides. We do plus or minus when we square root, but in this case, we know we're talking about the side of a triangle, so we know it's going to be a positive number. So I have a good reason to ignore that minus part. I'm just going to keep the plus. Now I want to put this in simple radical form. Yay, simple radical form. You guys love this one, right? So to go to simple radical form, I'm going to take my 108. I'm going to put it in a factor tree. It's an even number, so I'm going to go 2, half of 10 is 5, half of 8 is 4. That's even, so I can do it again. I got 2 and 27. 27 is not even, so I'm going to try 3. I know 3 times 9 works, and 9 is 3 times 3. So if I'm going to put this in simple radical form, I'm going to take all my little leaves here. I'm going to put them under my radical. So now I have x equals the square root of 2 times 2 times 3 times 3 times 3. When we break everything out, there's going to be a 2 that breaks out. There's going to be a 3 that breaks out. I'm going to multiply those together outside the radical, so I'm going to get 6 times the square root of 3. And once I have that number figured out, I'm going to take that, I'm going to go right back to my diagram. The diagrams are super important, you guys. Make sure you're drawing your diagrams. I'm going to come back to my diagram. I'm going to put my 6 root 3 right on my triangle, because now when I go to do my parts of my 6 trig functions, I can look right over to my diagram and see what's going on. I think I'm going to take a moment and just erase that x so it's a little less confusing. Oops, don't erase the radical though. There we go. So cosine is where we stopped because we needed the adjacent. So now I can go cosine is adjacent over hypotenuse, which is going to be adjacent side is 6 root 3 over the hypotenuse is 12. Tangent is going to be the opposite over the adjacent. So opposite of theta, go back to that theta, opposite is 6. The adjacent is 6 root 3. So now what we're going to do, I'm going to make myself a little bit of room here. I'm going to take this and move it over a tiny bit. I want to reduce these fractions, because when you go to put these in big ideas, they're going to want reduced fractions that are in simple radical form and rationalized. So I'm going to take this 6 over 10 up here. Nope, 6 over 12. Reduce it, divide by 6 on the top. I'm going to get a 1, divide by 6 on the bottom. I'm going to get a 2. Same thing on my cosine. The 6 and the 12 are going to reduce, so the 1's going to get multiplied by the square root of 3 that's still up there. So I'm going to have a root 3 over 2. My tangent, I got a 6 on the top, a 6 on the bottom. Now, just like we've been practicing with our rational stuff, we slash out the 6's. They don't go away. They turn into 1. So this is going to be 1 over root 3. Then we have one more little problem with this 1 over root 3. That is not rationalized. So we're going to do one more thing. Don't you love it how all of your algebra comes back right here? We're going to multiply by 1 and get that square root out from under the bottom of that fraction. So to do that, we're going to multiply by 1 in the form of square root of 3 over square root of 3. So I'm going to have the square root of 3 over 3. This is kind of messy, so I'm going to use my fun little toys here and highlight my simplified answers. I got a root 3 over 3 for my tangent. I've got a square root of 3 over 2 for my cosine, and I've got a 1/2 for my sine. Now I'm ready to take those numbers and get the reciprocal so I can get the last of the 6 trig functions. So I know cosecant is the reciprocal of sine, so I'm just going to flip that fraction over. You don't have to write the over one, but I'm doing it to make a point right here. The secant is the reciprocal function of cosine, so we're going to take our reduced form and we're going to flip it over. So we're going to have a 2 over a root 3. Excuse me, cotangent is going to be the reciprocal of tangent. So it turns out it's easier right here if we look at this simplified form and just take that, because remember the 1 over root 3 times the root 3 over root 3 is giving us the same number just in a different form. So we're going to pick the easy form for when we do the reciprocal. I'm going to take that 1 over root 3 and rewrite it as root 3 over 1. Now we only have one little issue left over here. We have this radical in the denominator of our second trig function over here. This root 3, that's not cool. So we're going to rationalize that one. We're going to multiply by square root of 3 over the square root of 3. And I'm out of space. I don't know if I can move this anymore. Let's see if I can do a magic trick here. Take all of this stuff. I can move it over a little bit. Oops, maybe right there. Okay, so now I can rationalize the, where were we? Oh, this root 3 over 3. So I have my pencil back. I'm going to go 2 root 3 on the top over square root of 3 times square root of 3 is 3. So now I have my 6 trig functions for the same triangle, trig ratios I should say, all in reduced form that have been rationalized. So I would enter those, if this was my question on Big Ideas, those are what I would put in my answer boxes on numbers 5, 7, or 9. This is not the same problem, but this is